All right, friends and neighbors, this is Professor H. Welcome back. This is another instructional video. This time we are doing part 2 of the IPv6 series. Now remember, this is from the Packet Guide to Core Network Protocols, Chapter 8. So if you have that, you can follow along. And what we started with last week, what you remember, or the last video, was an IP version for topology. And so we kind of worked through it. We did it kind of fast, but we were working through it. And we saw there the MAC addresses and the IP addresses that are generated and how transmissions occur, some of the packets that you might expect to see on the network. And now we're going to move to an IPv6 network. So what we're going to do is take the exact same topology and convert it to IPv6 and then see what happens. So what have we done? Well, in moving to IPv6, we want to do a couple of things. If we want it to be native, meaning we want to make sure that we don't have any IP version stuff going on, we're going to turn off all the IP version 4 stuff. We're going to turn off some addressing, some advertising, and some Windows garbage. So if you look at your protocol stack or the properties for your network adapter, all that stuff is disabled. So the only thing that's allowed on the network right now is IPv6. The other thing that we've got going on is that the interfaces for the routers are shutting down. And I'll show you why we do that later on. But we're trying to take this in stages. So first up, we're going to just turn on IPv6 on the host interfaces and leave IPv4 off. Now, the minute you activate IPv6, there's a whole lot of traffic that happens here. Now, it's sort of masked for you, usually because IPv6 is on by default, so you don't really notice this in all your other traffic. But if you've got no IPv6 enabled and then suddenly you turn it on, there's all of this traffic that's generated as a result. And we'll talk about what happens here in a second. So when we take a look at our stripped topology, we have the exact same topology that we had before, but this time there's no addressing. So then we turn on IPv6, and whoa, look at all this traffic that's generated. Now there's a couple of interesting things that I wanted to point out about the traffic that's generated. Now remember that this is stuff that I see on a particular host, and I've got a couple of things pointed out to you on this particular slide. Number one is that FE80 address. That's what we call the link local address. It's one that we see all the time. All hosts have a link local address that are on the IPv6 network. I've also circled that pair of colons there, and we're going to talk about addressing in another video, but I wanted to point this out to you first. This is how IPv6 shortens up network addresses. And then lastly, we see in that destination column a whole lot of multicast traffic, and that's one of the mystical, magical things about IPv6 is that we do have an awful lot of multicast traffic happening. Well, the next thing that I wanted to do is say, all right, well, now that we've enabled IPv6, let's take a look at the host IPv6 address. Now remember, we haven't done anything for the network properties yet, meaning that we haven't gone in and manually assigned an IPv6 address, and there's no DHCP version 6 running on the network at this point. So the only thing that the host gets is this link local address, this address that begins with FE80, extraordinarily common. A couple other things that I wanted to point out here are that this particular address ends with the hexadecimal combination of EC54. So we just want to remember that when we're looking at traffic there, and there's no default gateway here at all. Now this is a look at a host routing table. Host routing tables exist in IPv4. Hosts use the host routing table to figure out how they're going to forward traffic from their own network interface or interfaces. And we can see here that in the host routing table, I have in fact turned off all IPv4. There's no IPv4 here at all. And we can see that there are a number of address types here. We've got what effectively amounts to a loopback address for us. We've got our link local addresses, and then of course we've got to have the ability to answer up to all that multicast traffic, so we've got multicast entries in the routing table as well. We don't have anything special going on the network yet, and so there's not a whole lot in this routing table. Okay, our next step is to add the router. Now, to do this, we're going to not only enable the interfaces, but we're also going to give the routers what's called a global unicast address, because the router is going to be used, obviously, to get us in between networks, and we want to have, we want to be able to identify our different IPv6 networks. So you can see that the router interface on the left has the address of 2001.0401 and then :254, and with a network mask of /64. The right side interface looks really close to that, except in the second portion of the address we see 0402 there. Now initially, remember that all we're doing here at this point is giving the routers an IPv6 address and turning the interfaces on. At this point, also remember that the hosts are IPv6 enabled. Alright, so now what happens? Well, we can see here that we have a whole bunch of traffic generated as a result of those changes. Now again, I've pointed out a couple of things on this particular slide. We see that there's a lot of multicast traffic again. We see our friend the link local address, but now we also see those global unicast addresses being used on the network. Now these are coming from the router, and we might ask ourselves, what is going on? Now, one of the other things that becomes important to understand is that when you're dealing with an IPv6 network, it's not enough just to understand IPv6. I mean, everybody wants to talk about IPv6 addressing and changes to the header, but an integral part of an IPv6 network is understanding ICMP version 6. And we can see that there's an awful lot of ICMP version 6 here, and the primary purpose at this point is what we call neighbor discovery, and that's a big part of an IPv6 operation. Okay, so if we go back to the hosts, we can kind of see some changes going on here. Take a look at some of the blanks that have been filled in here. Now we have an IPv6 address for the host. Note that we've taken that suffix that was part of this, and we've appended the network address to this particular host address. I haven't done anything to the host at this point. All we've done is said, hey, listen, now you know where your router is, and that's really an important idea. This host now understands the network that he resides on. Still got his link local address, still got that FE80 address sitting there. But now he's identified another link local address, and that is the link local address of the router there. The bottom at the one at the bottom, the default gateway, and that is ends with 3240. Now, what's interesting about this is that you're not using an IP address as we normally think of them to contact your neighbors. A lot of times we use this link local address to talk to our neighbors. That doesn't mean you can't use other addresses to do the same thing. Alright, so let's take a look at our routing table for the same host. This is the same one that we looked at earlier, and we can see now that we're starting to populate this routing table with a few more things. We know a little bit more about the network. We have an understanding of the global unicast addressing that's being used. So we have a better feel for the neighborhood, and our routing table is growing a little bit. Well, let's take a look at some IPv6 pings here. So these pings work. You can see the commands that I've used here. I'm pinging a link local address. In this case, the top ping there is pinging the link local address of the router. But then I turned right around and did the exact same thing, same device, but I used the global unicast address. So you can see that you can ping both of them. By the way, ping 6 also works on a Windows machine. So you can see that you can ping both the link local and the global unicast addresses for a particular node. They answer up to both of them. And just as a reminder here, pings are not actually generating traffic in the sense that you don't send a ping across the network. A ping actually sends an ICMP echo request. All right. Well, that will about bring us to the close of this this IP version 6 video, but I want to make note of a couple of things before we shut it down for good here. In IP version 6, you may have noticed in those captures there's no ARP. You're doing neighbor discovery to find folks. So we don't have any ARP requests and ARP responses in IP version 6. Hosts can have several different addresses associated with them, and those addresses can sometimes change. So if you bring an interface down and then you bring it back up again, you might actually have a different address, and we'll talk a little bit more about that later on. Addresses are automatically generated, so that is part of what we saw here. There's also this EUI64 format. We'll talk more about that. Lots of multicast in IP version 6. We have multicast in IP version 4, certainly, but we have a very particular process for it. But in IP version 6, we see a lot of it just to handle some normal operations. We have some new MAC addressing, not to say that that multicast addresses go away, but we have a different format for them, and again, that'll be part of our next video. But another important thing to remember is that even though IP version 6 looks different, there's traffic that's different, the addressing is strange, got to figure out how to get used to this, the basic operation of a network is still the same, and that includes things like routing protocols and masking and stuff like that. All right, thanks everybody. I appreciate you watching and hanging out here on the YouTube channel. I will be putting out another IP version 6 video, and we'll talk mostly about addressing in that one. Take a spin by brucehartpence.com if you're interested in more content and see what's going on out there, and also the other portions of the YouTube channel here. And remember that this particular set of videos is coming out of Chapter 8 of the Packet Guide to Core Network Protocols. Thanks again for watching, and may your packets always reach their destinations.